Meet our friendly robot. This in fact is a continuous path welder robot. That means that it welds seams on cars together, and it's fairly typical of many similar robot machines which are involved in manufacturing cars these days. Cars, for example, like the Fiat Strada here, a car which is sold on the fact that it was designed by computers and made by robots. But then there are lots of obvious advantages in using a robot which can remember exactly the function it's asked to perform. In this case, to trace a simple triangle and repeat it over and over at a consistently high standard. Now, a robot is able to do all of this because it has its own brain, a tiny microcomputer. And it's microcomputers that we're interested in here, thinking about the role that they have to play in the making and the running of our cars, not just today, but certainly in the future too. Now, there are lots of people, me included, who think that microcomputers sound very complicated. So to help us through the maze, I have with me Richard Peaty, who's the Engineering Director of ERA Technology, perhaps better known as the Electrical Research Association. So, Richard, we hear a lot about the magic microchip. What exactly is a chip?
A chip is a tiny sliver of pure silicon, about the size of your little fingernail, on which are planted about 30,000 transistors. That's as many as you get in 1,000 ordinary television sets. And these are all connected together so that you can form a complete complex circuit in a tiny package like this. Now, this one's a memory, but a computer will be pretty much the same size.
Now, what sort of tasks is a microcomputer best suited to?
Well, two things. First of all, to collecting and assessing and displaying information. And secondly, to control. Control, particularly when you need accuracy or exact timing or speed.
So thinking about cars in particular, in what areas then might we expect to find microcomputers?
Well, across the whole spectrum of things. In making cars, in the controls under the bonnet when you're driving them, in providing the driver with more information, and as aids to servicing.
Well, let's start off with making cars, because we've already seen that microcomputers have a very important role to play there. What sort of jobs can they do, in fact?
Well, they can do the repetitive, which is very often boring, or dirty jobs. You've seen the use of a robot there, the seam welder. Again, they can be used for paint spraying, and at the end of the production line, or the end of the engine assembly line, used for the final test. They can do the testing quicker and more accurately than man can.
Do you think that from the worker's point of view, microcomputers will be taking the skill out of making cars?
They'll be moving the skill. The robot will perform no better than the man who taught it. But once it's been taught, of course, it's very consistent. I think if robots had been invented first, we wouldn't ask people to do some of the jobs which are involved in car assembly.
I'm sure that's true. Well, leaving making cars behind us for a moment, what about the help that microcomputers might offer the car owner and driver?
Well, there's the things he sees and the things he doesn't see. And I think the things he doesn't see are more important. They have to do with engine management, transmission control, and so on. And we've got here an example of the engine control, or rather here, ignition control in the Citroën Visa. Now, a great deal of this little car, which is a very economical one of the cheapest cars on the market, has obviously been borrowed from the old 2CV, which has been around for a very long time. But the ignition control is completely new. Now, this is not a full-blown microcomputer, but it's using exactly the same technology, and it's achieving the sort of results which you'd expect. That's to say, the ignition advance and retard is very much better matched to what the engine needs under all conditions of running.
So it's much more efficient then?
Well, that's right. And this unit here, this electronic unit, replaces the mechanical contact breaker and mechanical advance and retard mechanism which you'd find on a conventional car.
Well, if this is what you'd find in a car at the bottom, really, of the car market, what then might you expect from a more sophisticated and bigger car?
Well, to see that, let's have a look at the BMW over here. Well, on the BMW here, we've not only got computer control of the ignition, as you've got on the Visa, but also the fuel injection system. And to give a very much more precise control over both of these, it takes account not only of the load on the engine and the speed, as it does in the Visa, but also of other factors such as the engine coolant temperature, the air temperature, and the air pressure.
Anything else?
Yes, I think it's a very important one is safety, and that is an anti-skid braking systems.
Anything else under the bonnet?
Yes, there's cruise control, and we've got cruise control allied with an onboard computer in an Allegro.
And I think probably to see those two facilities working well, we should have a look at a recording which we made in the car earlier on this morning. Well, first of all, the driver can preset the cruise control to a speed of, for example, 60 miles an hour. And at the same time, he can tell the computer that the journey he's setting off on will last about 20 miles. So off he goes, working his way up through the gears, and as he does that, he can see an instantaneous readout of the fuel that he's using. When he gets as far as the motorway and he's doing, for example, 40 miles per hour, he might decide that he wants to move up to his cruise control speed of 60 miles per hour. So he just pushes the cruise control button, takes his foot off the accelerator, and lets the car move up at its own speed to the preset speed of 60 miles per hour. And incidentally, if there's any sort of accident or emergency, then he can always override the cruise control by just pressing either the clutch or the brake. Well, later on in his journey, he may decide to have some sort of assessment of how he's getting on, so he can immediately check readouts for the amount of distance he's travelled, how much he's still got left to go, the estimated time that it's going to take him to get to his destination, and his average miles per gallon during the journey. Richard, are these onboard computers just elaborate toys, do you think?
No, not entirely, I don't think so. I think they can serve a useful function in watching the instruments, warning the driver of any impending failures. I think if it brings home to people the heavy cost of hard driving, you've got a running measure of MPG, and for that matter of average speed, and show you in fact use a lot more fuel and you don't save a lot of time. If I had a concern, it'd be about a bit of a distraction. If I'm going to brake hard, I just hope the chap behind isn't fiddling with his computer.
I hope not too. Are they reliable though, these computers, do you think?
Parts in the car should be at least as reliable as a good pocket calculator. If I had a concern, it'd be about the sensors underneath the engine, possibly even on the drive shafts, where they're exposed to temperature, vibration, salt spray and so on.
Well, now you mentioned earlier on, Richard, that servicing was one of the areas where microcomputers might be useful. What did you have in mind?
Well, something very much like this. This is the Ortrac mobile diagnostic unit. You've got a van here with a computer in the back. It's got a teleprinter to provide you with a permanent record of all the work that's been done, the checks carried out and whether they're within limits. There's a display there so the chap can see what's going to go onto the record. And here he's got a handheld unit which provides him with a prompt of all the tests to be carried out. Now all the tests for each particular type of car and each variant of it are contained in the computer's memory. And the computer is connected up through sensors. Some of these come to the car electrics, others, for example, to the inlet manifold as a pressure sensor, and as an exhaust gas analyzer on the tailpipe. So it's prompting him not only to do the visual checks, but start the engine at the right time. When you start the engine, in 5 seconds it can run through a complete series of tests from which you can infer things like compression ratio, and if the thing is outside limits, it'll stop and warn him. And so altogether you've got something which does not replace the skilled man, but it tells him what he's got to do next, and he gets through his work very much more quickly, and you've got a printed record at the end of the results.
And it only costs about £20 to have it visit you at home.
Yes, that's right.
Does it mean then that as we introduce more computers into our cars that we actually need computers to service the computers?
You don't need them, but it's a very much easier and quicker way of making the best of the skilled labour in garages.
Well, looking ahead to the future, Richard, do you think that we're going to be glad for the introduction of microchips to our cars?
I think we're probably going to take it for granted in exactly the same way we take for granted electric motors. After all, nobody ever thinks of the electric motor. It's a component. You've got them in the front, from the starter motor through to the tailgate wash. Provided they're reliable, you do what you want, that's fine. Exactly the same with the chip. Chips used carefully with proper engineering can make cars better, they can make them more reliable, and they can make them more efficient. And I think that's what we're glad for.
Richard, thanks very much indeed.
Thank you.